All right, so we're moving on to what we call compositional functions. So the question reads, how do you find f of g of x and g of f of x given f of x equals 2x minus 3 and g of x equals x squared minus 2x? So I talked about domain and ranges of functions. So I'm going to describe what the compositional function looks like, okay? All right, so we have our original x, okay? So independently, these two functions can act in different ways. So let's say that, actually, let me write real value numbers. Okay, this is just an illustration for now. Okay, so independently, these two functions can take x's from the real number set, and it can lead it to different places. So this is g, this is f, and we have the range of g of x, and we have range of f of x. Okay. So like in my previous illustration, the domain and range, I've already described that. So independently, these two functions work, right? So they take values. So this is the real number set, right? I just didn't draw, I guess a better accurate drawing of this in this context would be like a Venn diagram kind of thing, where we have like the domain of G and the domain of F, where they share values entirely, but they can also not share values, right? This is the Venn diagram. So let's just denote these as like x of G and f of G, x of F, okay? This is how you don't really write it, but I want to illustrate this entirely, okay? All right, so you have the domain, right? So these functions can work independently. But when you have a compositional function, it looks more like this, okay? So it really does matter which way how you read it. So in this way, we read f of g, right? So that means that g of x is the function within function f, and this is what it looks like, okay? So let's say that we have a pool of x's, and so we have the domain of g. Okay, so this is a domain of g of x. Okay, so we have the domain of g of x, which is I'll just label it x. Okay, and a compositional function works by applying the function g first and producing what we have as the range of g. Why does this happen? And the range of g is g of x. Okay, so I'll denote this as g of x. All right, range of g of x. So let's say that the range of g of x is the middleman or the domain that's going to be acted out for the function of f. Okay, so that means that function f takes the valid values of g of x, and it uses that to produce its own values. Okay, so f, and it produces what we have here as f of x, which is the range of f of x. Okay, so that's how a compositional function works, and I'm going to label this as f of g. Okay, if it was g of f, then it will be switched, right? So we'll have the domain of f first, applying function f to go to the range of f, and using the range of f values to apply the domain for function g to produce the range of g of x. Okay, now in our particular example here, we have polynomial functions. So we know that the whole real number set is valid for the domain for both, right? But in a general case, there are some compositional functions where the final range of f of g of x is not going to be the same as the range of f of x independently. And that is determined by by the domains of the specific functions itself. Because sometimes your function g may produce values where it does not fit into the domain of f. Okay, and because of f of g of x, sorry, and because of that, they have to be excluded from the pool of values for the domain of f of g. Okay, but that's super complicated stuff. In this case, we have polynomial functions, so we're just going to assume that everything is up for grabs here. Okay, so let's calculate f of g and then let's calculate g of f. Okay, so how I like to write this out is when we say f of g of x, I like to write it out. So we see here that the g function is the one that's within the f function. Okay, so we're going to write out the f function first. So the f function is 2x minus 3. So I'm just going to leave a gap here. So I'm just going to leave a bracket here for now, minus 3. Okay, and this bracket is where g of x is going to be. Okay, so we can write g of x. So this is equal to 2 times, so f of g of x is 2 times g of x minus 3. So now that we have established that, we can just sub in g of x, right? So that's going to be 2 times x squared minus 2x bracket minus 3. And if we were to expand that, we would get 2x squared minus 4x minus 3. So we see here now that we have gotten a quadratic function from the compositional function f of g of x. Okay, cool. What if we did it the other way around? Okay, so now f is the inside function, so we're going to sub it into our g of x. Okay, so g of f of x, what is that going to be? So we see here that we have a bracket here for this, x squared minus 2 times the bracket. And we're going to put our f's in here, okay? And if we put our f's in here, we get f of x squared minus 2 times f of x. So we see here that g of f of x is basically f of x squared minus 2 times f of x, okay? If we were to sub that in together, we get 2x minus 3 squared minus 2 times 2x minus 3. If we were to expand this first term, we would get 4x squared minus 24x plus 9. And we'll expand this and we get minus 4x plus 12. And if we were to simplify, we get 4x squared minus 28x plus 21. Cool. So we also got a quadratic function here. So these are the two compositional functions, and they have their own domains and ranges. Okay. So last thing to note, the domain of f of g of x is going to be the domain of g of x. Okay, and the range is going to be the valid values of f of x, of f of g of x at the end. Okay, so that might exclude some values that are that define independently g of x, but when you do f of g of x, it doesn't make it define anymore. Okay, and we'll be covering that a little bit further as we go along. But for now, we can move along. Okay, did I expand wrong? G of f of x. Hold up here a second. So g of f of x, 2x. Oh, they added wrong, I believe. I also added wrong. This should be 12. And this should be 16. Sorry about that. Did I add anything else wrong here? So 2x squared negative 12x plus 3. Why did I write? Okay, sorry guys. I'm a little bit. I'm making a lot of silly mistakes today. It should be 6. This should be 15. All right. Hopefully I didn't make any more mistakes. 4x squared minus 16 plus 15. I think I'm good. So here the junior tutor forgot to write out the last term. They didn't include the 9 here, so that's why they have a 6 instead of a 15. So for the solution is almost correct for your g of f of x, you expanded the 2x minus 3 squared term incorrectly. And I almost expanded it incorrectly. That's why you always double check your work, guys.